so let's go back over this again. Let me see if I can switch screens here. Please, let me switch screens. There we go. Alrighty, it says right here, you have to kind of really read and be careful when you're reading. It says she has researched and found that of 12 stores, so she had a sample size of n equals 12. And the average startup cost is this with a standard deviation of this. So what she's saying is she took a survey of 12 stores, and the results of the survey gave her the average startup cost, and then the average standard deviation. That means that standard deviation, it's provided in the problem, yes, but this standard deviation that's provided is from the sample of 12, which means that it is a sample standard deviation and not a population standard deviation. So knowing that information, Rowan, what would you say now? You got it? Okay. I'm going to let you work, excuse me, I'm going to let you work that problem on your own in the background as we work with other students. And if you don't get the correct answers, let me know and we'll come back to it. Does that sound fair? Great. Okay. Who else has a question for me? Let me check my cell phone for texting. Getting lots of code words, but nobody with a question as of yet. So, questions? Have you all, okay, let's just have an honest answer here. From everybody who's currently here, let me see all who's here. Have you actually started Mod 8? I mean, we have an exam in 2 days. Have you started Mod 8? It's okay if you haven't. Just be honest so I know. Very good. Okay. Very good. Very good. Are you all having any questions with Mod 8? Or are you just flying through it? Okay, right. Marjorie, thank you. Jordan, you haven't yet? That's okay. No problems? Not yet. Okay. It is a lot of information, Riley. You're right. Let me ask you this. Okay, Jessica, we're going to practice that. That's a very good thing to start with. Could the people who have started Mod 8 just pop in and tell me what number problem you've gotten to? So in other words, if you've started it and you're on problem 4 of 20, I don't know how many there are, but if you're on problem 4 of 20, that gives me an idea that maybe I want to look at problem 6, 7, and 8, and we'll get you all past that. If everybody's on 20 out of 20, then that also changes things a little bit. So give me some information on what problem you're working on while I head on over to this area, and we're going to bring up Mod 8, because I really want to spend as much time working on Mod 8 today, because the last several sessions we've spent on Mod 7. And there are 18 problems, so let's see here. So, Riley, you've gotten to problem 3, is that what I'm understanding? So you've done 1, 2, and 3, okay. And Jessica, have you also done 1, 2, and 3 then? Not done with 3 yet. Okay. Alrighty. So here's what we're going to do, guys. Recognize that my numbers are different than your numbers, okay? It's not in your best interest for you to sit there and try to solve these in the background as I'm solving them. It's more important for you to follow along and get the concept and then go back and solve your numbers with the understanding of concept as opposed to just trying to get your homework knocked out. I can extend homework dates without penalty, okay? So don't worry about that. It's about understanding the concept in time for the exam. That's what's important, okay? But part of that is getting the homework done, okay? So let's see if we can get some of this progressing forward. And I'm videotaping this, and all the notes will be downloaded also. So I will upload a video as well as the actual notes so that you can go back if need be and review this, okay? So let me just look at some of these and see where I want to start. I'm going to start on number 4 since everybody else has gotten to number 3 here. let's see here. Let me go ahead and wipe that out and wipe that out. And let's just start working. We've got an hour and a half to 2 hours. Let's see here. We've got about an hour and a half or so. Let's just start working as many of these problems as possible as we get through. I need to create some some notebook paper. Yeah, Tim?
Where's your phone?
My phone's over here to the right.
Hotspot now?
Yes, make sure it's plugged in, please, so I don't end up having a dead battery. Does that make sense? And I think Zachary's Bluetoothed off of it right now. Just put it on the windowsill. If I really can't have you take it in the other room because I need to keep in touch with my students.
I don't need it.
Okay. Thank you.
I didn't want to connect to the Wi-Fi.
Yeah, you can't right now. Thank you. I appreciate
I
that.
didn't think I could.
Thank you. It's a pretty day outside. You should go sit outside and do your work. It's pretty. Y'all should go for a swim. You okay, Z?
Oh, you need it?
I'm not. I'm just getting some work uploaded real quick. About to start. Okay, so does everybody have your tables ready? Have your formula sheets ready? Does everybody have everything ready to go? And your calculators. Let's make sure everybody has everything. You have pencil, paper, calculator, tables. You need your Z tables, your T tables, and your formula sheet. Get all that handy because that's what you're going to need also for the exam. So go grab your stuff if you don't have it. And we're going to get busy just working problems. So here we go. The first one here says, ooh, I almost grabbed a real pen instead of my stylus. That would have been bad. Okay, so it says find the p-value for the test statistic z equals 1.5 for the following null and alternative hypothesis. So our null hypothesis is the population mean is 19. So that would be written as mu, H naught is mu is equal to 19. The next one says our alternative, they put HA, I'm going to put H1. The population mean is less than 19. So mu is less than 19. This tells us it's a one-tailed test and it's a left-tailed test. And I know it's a left-tailed test because this points in the direction of the tail of interest and it's pointing to the left. So I know I'm doing a left-tailed test. It says that I have a Z statistic of 1.5. Again, I don't like this problem. I'm just going to tell you that, and I'm being recorded, which is a danger zone. I don't like this problem because one of the ways I tell my students to be careful when you're taking my exams, if you end up having a hypothesis that says your area of interest, okay, your rejection area is right here to the left, and then you end up with a test statistic that's positive, that is a clue. In reality, that's a clue that you've got something backwards, okay? Either you have the hypothesis, the alternative hypothesis backwards, or you've made a calculation error. Because if you have a left-tailed test, you should have a negative Z value, okay? I'm just telling you like it is, okay? Alrighty, with that said, here we go. These things are randomly generated by a computer, and so we have sometimes things that don't make much sense, okay? So this would be our negative Z star value, which we don't have because we're not doing a test with an alpha level. It's not giving us an alpha level, but it's saying, let's find the p-value, okay? So in this case, since it's a left-tailed test, the p-value is going to be all of this area here to negative infinity, okay? It goes left. It's this area under the curve. It goes the same direction that your sign here is pointing for your alternate hypothesis. So we're going to pull up our our Z tables. We're going to pull up 1.5 and let me see here. There we go. Okay, so we're going to pull up our z-table, and we're going to look up 1.5. The good thing about our z-tables is the fact that it does give the cumulative from negative infinity all the way over. So when we get over here to the positive side, this area that's shaded right here is actually our answer. So all we have to do is look up 1.5. So 1.50 is 0.9332. 0.9332 is going to be our answer right here. Let me get to a pen. 0.9332. And I can bebop right on over here and put that in on WebWork and put that in right here. 0.9332 and say submit answer, and it's going to check and say I did well. How's everybody on that? Everybody good so far? Does everybody understand why it's a Leftel test? Why I calculated the p-value from the test statistic to negative infinity? Very good. Okay, anybody else? Alrighty. So here we go. Back to the other one. The other one is trickier. Yep, because it's a two-tailed test. So let's bring it up for two-tailed test right here. And let me scoot this up just a little bit. So for part B, it says the population mean is 19. So H naught is mu is equal to 19. Your alternative, H1, says the population mean is not equal to 19. So mu is not equal to 19. Alrighty, so here we go. So we go like this, we go like this, and not equal to means I have a two areas that I need to be concerned about. Because the reality is if I was doing this with alpha, I would be putting half of alpha here, half of alpha here, because it's a do not equal. And I would have a negative z star, and I would have a positive z star. Okay? Now the next thing I need to do is plot my test statistic. And it says my test statistic again is 1.5. This makes better sense. We can have a positive one with a not equal to, and we're going to put 1.5 right here. Now, this is very important, when you have a not equal sign, like right here, okay? When you have a not equal, find your test statistic. You're going to highlight the area from your test statistic to the closest infinity, okay? So in this case, I'm going to highlight to positive infinity because positive infinity is closer than negative infinity from my test statistic. But because it's a two-tailed test, I have to multiply this by 2, and I must also plot negative 1.5 and then highlight to negative infinity over here also. That is my p-value, okay? My p-value is actually going to be equal to, for my two-tailed test or part B, my p-value is going to be equal to the probability that z is less than negative 1.5 plus the probability that z is greater than positive 1.5. Okay? So it's the yellow area here. This is yellow. This is yellow. This part right here is this right here. This right here is this right here. Because it is symmetrical, okay? Because it is symmetrical, I know for a fact that the area under the curve for this is equal to the area under the curve for this. They're the exact same. So really, all I need to do is I need to say that the p-value is equal to 2 times the probability that z is less than 1.5. okay? Because this and this are going to be the exact same number, so I can just multiply it by 2. So I'm going to come in here, I'm going to say 2 times, and we're going to look up the area under the curve to the left of negative 1.5. So grab out your tables, look it up for yourself, and let's see if we all come up with the same answer. So negative 1.5. Negative 1.50 is right here, 0.0668. 0.0668. So that right here, I'm going to put 0.0668. I'm going to grab my calculator and throw it in, and so I get 2 times 0.0668, and that is going to be equal to 0.113. Oops, sorry. 336. So 0.1336. And come back in here. 1336. 1336. Submit answers. And we're done. Okay. How's everybody on your comprehension of understanding the concept for the two-tailed p-value, or the not equal sign p-value? Very good, Kaylin. Anybody else? Good. Thank you. All right. All righty. Very good. Thank you. Let's look at the next problem. Let's just bring it on up. And I'm thinking, guys, I teach tomorrow online from 11 o'clock. I think it's 11 o'clock till 5 o'clock solid. And, but I think that I probably could come online about 9:30 and give you guys another hour from 9:30 to 10:30. I have to check my schedule. So keep an eye out on announcements to see if I make an announcement that I can meet you guys at 9:30 tomorrow morning. Alrighty, so here's our next one. It says, Dan thinks a certain potato chip maker is putting fewer chips in their regular bags of chips. From a random sample of 16, so n equals 16 bags of potato chips, he calculated a p-value of 0.009 for the sample. Okay, so that would be the p-value for your test statistic. At a 5% level of significance, is there evidence that Dan is correct? Let me go ahead so I can write the answer in your notes instead of just solving it here on the video. Let me go ahead and cut and paste this in. Insert screen clipping. Here we go. Okay, so at a 5% significant level, is there evidence that Dan is correct? Remember, in order to reject your H naught, the rule is that your p-value must be less than alpha to reject H naught, okay? So for this one, here's our p-value. Our p-value is 0.009, and that is less than 0.05. So is there evidence that he is correct? The answer would be yes. We have a live mic for whoever just joined us. For part B, it says at a 10% significant level, is he correct? Well, again, 0.009 is less than 0.1, so yes. Again, we have a live mic. In a statistical test of hypothesis, we say that the data are statistically significant at level alpha if p-value is less than alpha, which would be B. Okay, so let's go in and put those answers in and make sure WebWork likes my answers. So we type the word yes, and yes. I hope it's not case sensitive. And the p-value is less than that. Submit answers. Very good. Okay, so let's come in here and Saud, you have a live mic. Thank you. Alrighty, so let's go back to our next one here. Is everybody good with that, by the way? Before I move on, let me ask a question. Is everybody good with the fact that the p-value has to be less than alpha in order for us to reject H naught? Okay. Very good. Okay, let's look at our next problem. The next problem says, let me just go ahead and insert this into the notebook. So insert screen clipping. Oh, I already have part of the answer in there. Sorry, we'll go through the calculations though. It says in the article of the Washington Post on March 16th, it stated that nearly 45% of all Americans have brown eyes. A random sample of N equals 56, that's what that tells us, 56 students found that 35 have brown eyes. That would be X. X is the number of people or observations that qualify for what you're studying, okay? So what we did is we did a sample of 56 people. So N is equal to 56. And we either said or we observed the color of the eyes. If they said, yes, I have brown eyes, yes, I have brown eyes, then that is going to be X, okay? So we had 35 people. 35 people said yes. Therefore, remember the three dots like that means therefore X is equal to 35. And P hat is equal to X divided by N. So it's the number of people that qualified divided by the total number of people in the survey, okay? So let's keep reading. Give the numerical value of the sample proportion P hat and find the value of the test statistic. So our P hat is simply going to be 35 divided by 56. And if you grab your calculator, let's verify that that is the 53.57. 35 divided by 30, no. 35 divided by 56. Did I write that down wrong? 45 by 56. Hold on. 35 divided by 56. Am I just... Am I doing a calculation wrong? 35 people, 35 of them, so it should be 35 divided by 56. And I'm getting 0.625. Is everybody else getting 0.625?
That's correct.
So give the numerical value for the sample portion P hat. Oh, let me check my answer. Maybe that's not the right answer. Oh, no wonder. Okay. I don't know why I had that number in there. Okay. Have no idea. So let's put in 0.625 and let's see if that one's correct because that should be correct. I just assumed that other value was correct. Okay, there we go. I have no idea where that number came from. Okay, so come back down here and let's scribble that out so people don't get confused on that. 0.625. So right here is 0.625. Now for our test statistic, we're going to pull up our formula sheet, which is right here. And our formula sheet, we're going to go to page 3 or 4. I think it's page 4. Yep. So here is our test statistic formula. So Z is going to be equal to P hat minus P divided by the square root of P, Q divided by N. So let's go ahead and write that on in there. And I'm going to switch ink colors real quick and scroll up just a little bit. So Z is equal to P hat minus P divided by the square root of PQ divided by N. Now, P is equal to 0.45. If P equals 0.45, Q is equal to 1 minus 0.45, which is equal to 0.55. Kind of ran out of room right there. So P hat is 0.625, so 0.625 minus P, 0.45. Whoa, sorry about that. Let's try that again. 0.45 divided by the square root of. Now this is p, not p hat, okay? So it's 0.45 times 0.55 divided by n, and our n is 56. So we're going to grab our calculator, we're going to throw this in our calculator, and turn it on, clear it out. So make sure you overuse parentheses. So it's parentheses 0.625 minus 0.45, close parentheses, divided by the square root of 0.45 times 0.55 divided by 56. I like to bring it out from underneath the radical. You don't have to though. And your test statistic is going to be 2.63. I'm only going to go to two significant decimal places simply because the z only goes to 2. Okay, so it's 2.63. So 2.63. 2.63. 2.63. And let's go in and put our answer in. Oh, it says 4, sorry. Got to read directions, don't we? So that would be a 2-4 after that. So 2-4. 2-4. Had to round the 3 there to 4 because there was a 5. 2-4. So let's put that in. So 63.24. 63.24. 2.6324 and submit answers. Did everybody understand? This was the problem that said my answer was incorrect even though you said there was no mistake. Let's see, what number is this? Number 6. I think I got an email back this morning, Kelsa, and that should have been corrected. So please, if you're able to check that right now, go ahead, and if not, just after class and send me an email, because I did receive an email first thing this morning from the person who heads up the stats elements of statistics at UWF, and she said that she expanded the tolerance to so we shouldn't have an issue. It still says it's wrong unless I made a mistake. What are your numbers, Kelsa? Can you post like your p or your p, okay, that gives you in the problem, and then post your n and your x, and I'll run the numbers real quick. Okay, so n is 59. What's your x? How many people had brown eyes? That would be your x. X is 42. Please give me your p when you get a chance. So your p hat should be 42 divided by 59. So there's your p hat. Is it telling you? And your p is 0.45. Very good. So for your p hat, did you put in 0.7119? So 0.7119. Put that in. Okay, so it said that was right. Okay, so Rowan, you had, it wanted, so that actually, that's significantly different, Rowan. If you could email me, if it's still like that, Rowan, if it will not take the correct Z based on the calculations, please send me a screenshot of that. I need to get that corrected if it still isn't corrected. Okay, so Kelsa, let's see here. So we're going to have parentheses. Oops, let me do it this way. Parentheses. 0.7119 9 minus 0.45, close parentheses, divide it by square root of 0.45 times 0.55 divided by 59, and I get 4.0437. 4.0437. That's correct, and it's saying it's wrong. I'll let you check your own, Saud, because we've already identified that there's a potential problem. So Kelsa is saying that that number is still wrong. Okay, please send me a screenshot of that. Okay, just send me a screenshot and I will re-elevate it right back on up. Thank you very much. So if the question said to get the p-value of that question, we would look at the z-table again. Yes, and if this was your test statistic at 4.04, okay, when you come into your z-tables here, if you look at the very bottom, there's a message at the very bottom. It says for z values of more than 3.49, use 1.000 to approximate the area. So in this case, if your z value was 4, your p-value would be equal to 0. That's how you would use the tables to calculate that. Alrighty? So, alright, so let's look at another problem. And so it's a possibility what may have happened. So everybody who's listening, if for that problem, for problem 6, if your problem gives you the wrong answers here, for everybody who has that for this problem, send me a screenshot of it and I will elevate it up, because I think what possibly happened is, I looked at this the other day, and I elevated it up, and I think what possibly happened is she just corrected my numbers. Because you can go, what can happen is we typically have 6 to 8 different versions of the problem for the students, so that way all the students don't have the exact same problem. And we can have 2 scenarios going on, where a subset of those 8 different iterations are having difficulties, or the whole set is having difficulties. And I think she looked at it as maybe a subset and only corrected mine and didn't correct everybody else's, where it sounds like it's probably the whole situation. So we'll look at it and see. Or maybe I'm thinking of a different problem. Who knows? That could be the case too, but I don't think so. Alrighty, so it says from generation to generation, the mean age when smokers first start to smoke varies. In a survey of 27 smokers of this generation was performed to see if the mean starting age was greater than 17.9. The sample mean was 19.9, and the sample standard deviation was 2.8. So we have the sample standard deviation. What does that tell us? I'm going to come back here and wait for your answers. What does that tell us, everybody? That's right, Jessica. Very good. Excellent. High five. I wish I could insert a high five thing. So very good. Okay, here we go. So back to the problem. So do the data support the claim at the 5% level? So the first thing is the mean smoker. So let's see here. From generation to generation, the survey showed it starts at this, is greater than this. The sample mean was this. Okay, so mu is equal to 17.9 is going to be the first option. Submit answer. Yes. Okay, the next option is, what is N? N is the number of people we surveyed, which is 27. So that's going to be 27. Submit answer. There we go. I kind of always do it after each one just to make sure I haven't gone astray. I don't know if you all do the same thing. X bar, it says, what is X bar? And it came in here, it said the sample mean is 19.9. So that's going to be X bar, 19.9. There we go. Next it says, sigma is equal to, it didn't give us sigma. It gave us the sample standard deviation, and nowhere is it mentioned what sigma is. So that's a not given. And then S is going to be equal to 2.8. Where's 2.8? There it is. And we'll submit those answers, make sure we're on the right track. And then the last one says, what is the level of significance? That's alpha, so that's 0.05. 0.05 right there, because 5%, when we convert it to a mathematical number, is 0.05. Alrighty, is everybody good with that particular problem? Excellent. Very good. Thank you. Alrighty, here we go. Next problem. It says a random sample of 24 hard specimens of rock was analyzed for organic material. The sample mean was found to be 5.2 and the sample standard deviation was 2.9. Do you think it's reasonable to suppose that the mean organic content of the rock is greater than 4? Use a level of significance at 5%. So let's say, I'm gonna put this in just a second, but let's go ahead and do what we can on this part real quick. It says, what is the null hypothesis? So a random sample of 24 hard specimen rocks was analyzed for organic material. The sample mean was found this. Do you think it's reasonable to suppose that the mean, so we're gonna be dealing with the mean, so that's gonna be mu, mean content of the rock is greater than 4. So we can put equal, and then this one here is going to be 4, because that's, let's see here, random sample of 24, the sample mean. Yep, okay, so let's double check this. It may want this one here. You could also put this one here to be less than or equal to. Let's make sure it accepts it, because it should accept that. See, it's not. That's wrong. That's irritating. Okay, so on your web work, make sure you put equal, because all you have to do is make sure that it's opposite of what this one is. And the alternative is going to be greater. This is going to be mu, because we're testing that it's greater than 4. It's greater than 4. And so this just has to be opposite of this. So it should accept this as an answer. If somebody can get a screenshot of that and send that to me, I will see if I can get the department to support me on that decision. It is the right answer. We'll see. Okay, so there we go. Now it says, is the statistic a T or a Z? Well, let's go back up here again. A random sample 24. Mean sample was 5.2 and the sample standard deviation was 2.9. So we have the sample standard deviation. So that tells us what, everybody? T or Z? Very good. Yep, excellent. Okay, so we're going to put in a T. And then it says find the p-value. So let's find the p-value here. Did I put the T in the wrong spot? Oh, I guess I did. Sorry. I thought that went there. I guess not. I guess it goes here. Ah, there we go. Let's try that again. Submit answer. There we go. Alrighty. So we need to calculate our test statistic. So let me go ahead and import this into where I'm going to do math. Here's our math. Insert. Screen clipping. Oop, I don't have the top part of that, but I guess that'll be okay. Here we go. Alrighty, so our test statistic is going to look like this. It's a T test about the mean. We're going to pull up our formula sheet, and it's one sample. So here is our test statistic right here. Hypothesis testing, one sample about the mean. This population standard deviation is unknown, so this is our test statistic. So let's go ahead and write that on in here. So we're going to know that T is equal to x bar minus mu divided by S divided by the square root of n, and parentheses around that and around that. Our x bar, so let's see here, x bar is equal to 24 samples, so N is 24. Was analyzed. The sample mean was 5.2. The sample standard deviation is 2.9. S is 2.9. And then we're going to say mu is 4. And alpha is 0.05. Is this a one-tailed or two-tailed test? It is a one-tailed test. Is it a right-tailed test or a left-tailed test, everybody? Right tail or left tail? Excellent. Yes. Very good. Excellent. Okay, so back to the problem. So we come in here and we're going to just plug in our values. So this is going to be 5.2 minus 4 divided by standard deviation 2.9 divided by 24 under the radical. And we're going to throw this in our calculator over here. Turn it on, clear it out, and we go parentheses 5.2 minus 4 parentheses divided by open parentheses always for this part down here. You'll get the wrong answer. 2.9 divided by the square root of 24. This part you have to come out underneath and then close like that and hit enter. And 2.0271 is going to have 4 decimal places. So 0.0272 is going to be to 4 decimal places. So 271. So that's 2.0271 is what I said. So let's put that in. So right here it's going to be 2.0271. I'm going to come back in here and make sure WebWork likes our answer. So 2.0271. Submit answer. Very good. Now it's asking for the p-value. Now, for the p-value here, guys, normally I would ask you to interpolate, okay? So on the exam, this is what I'm looking for. And then I'll show you how to solve it for this. Okay, so 2.271. Let's see here, hold it. We got to come up here and do our degrees of freedom real quick. So our degrees of freedom would be n minus 1. So df is equal to 23. Okay, so we're at 23 degrees of freedom, and our test statistic is 2.0271. So we're going to open up, and we're one-tailed test, 23 degrees of freedom. That's the important thing. So we're a one-tailed test, so we're looking at the top bar here. We have to come down to 23 degrees of freedom. So 23 degrees of freedom right here. And we're going to look for the interval that encompasses our test statistic. And our test statistic was 2.071, is that right? 2.0271. So I have to come in here and look. 23 degrees of freedom. 2.202. So we're not above this value because 0.6 is greater than 0.06 is greater than 0.02. So we're bound between these two values right here, okay? So our p-value is going to be bound between, on the right one I am, okay? We're going to be bound between the top two numbers here, so 0.025 and 0.05. That's all you're going to be able to say on the test is 0.025 and 0.05. So that's how we're going to write down for our p-value on the test, is that 0.025 is less than our p-value, which is less than 0.05. That's all you're going to be able to say on your test. And coming in here, we're going to bring up the link that I posted yesterday in announcements. So if we come over here to announcements, you're going to see that I posted a link. It's called the p-value calculator. And this is what you're going to have to use to solve your web work homework. So you're going to come in and it's going to say put in your test statistic. My test statistic is 2.0271, I think. Is that, if I'm wrong, let me know. Degrees of freedom is 23 degrees of freedom. The alpha level doesn't really matter because we're just getting the P, and then it's a one-tailed test, and so we're going to hit calculate, and our p-value is going to be 0.027198. So this is our p-value right here. And so we'll come and we'll copy this and put it right here. Paste. Oops. Well, we'll just leave it there and I'll handwrite it in. So it is 0.027, 4 decimal places, 0.272. We'll see if it takes that or if it wants significant digits. So 272, which is so close to that number right there. It's really kind of intimidating or whatever, I don't know. 0.0272. Hopefully I typed that in right. Submit. And it likes that, okay? And then we come in here and our conclusion. Now notice that, did they give us an alpha level? Yes, alpha is 0.05. So our alpha level is greater than our p-value, so we're going to reject that H naught. So we're going to reject H naught. There is sufficient evidence to conclude that the mean organic content of the rock is greater than 4. Here we go. How did everybody do? Any questions on this problem? Thank you. Everybody good? Okay. Okay, very good. So let me go ahead and highlight the other answers in here so in case somebody's just looking at the answers. So we reject H naught. There is sufficient and it's greater than. Okay, so there you go. Alrighty, let's look at the next problem. Yeah, I put it in the computer. So are you talking about for the interpret, are you talking about, so are you talking about this right here or are you talking about this right here? Which one are you talking about? Okay, so what I did is I brought up the web link right here and I put in your test statistic. I put in the degrees of freedom. I put in that it was one-tailed and I hit the word calculate. And when you do that, it comes back with that value. So I didn't have to do anything but input information and hit the word calculate. So that's how I calculated it there. In reference to looking at, in reference to this statement right here, you have to look at your test statistic and you look at the degrees of freedom and you come into your t-table under that many degrees of freedom and you find the boundary. So my test statistic is smaller than this one and bigger than this one. So you find an interval that surrounds your test statistic. And once you know that interval, then you're going to go up to the top and you say, I'm a one-tailed test. And so you look at these two alpha values and you know your p-value is between those two values. Okay. The next problem right here is number 9. So we're going to insert a screen clipping of number 9. Uh-oh, I didn't get the whole problem. Hold on, let me undo that. Undo. Let me see if I can adjust this so I can see the whole screen at one time. There we go. And insert screen clipping. So we're going to go the whole problem. There we go. Got it. Okay. And everybody, if you find this session valuable, if you notice we're down to like 6 students that are participating on a regular basis, encourage your classmates, because my class right now, boy, we've got strong A's. We have many students with A's, and I'm very fearful that those A's will not even pass the course at this point, or they're going to have to convert to an SU. Well, even to an SU, you have to have a 70% to pass. So a D is not passing for an SU. And I'm very concerned that they're not engaging and doing their web work. I'm watching that, and it's a great concern. So if you've got classmates' phone numbers and stuff like that, even though you haven't seen them since spring break, give them a text and just say, hey, how are you doing? Are you solving problems? And do you have any questions? Maybe we can work together. Pop in and attend Mrs. Boland's Tuesday, Thursday morning sessions. But just encourage anybody who you may have their phone number for that's in, or email address that's in my class that you're classmates with, please reach out to them and try to help them and re-engage, because sometimes it's better received from fellow classmates than from the instructor. So anyway, just thought I'd put that little SOS out. Okay, so a particular brand of tire claims that its deluxe tires average at least 52,000 miles before it needs to be replaced. From past studies of the tire, the population standard deviation, key part right there, is known to be about 8,000 miles. A survey of owners of the tire designed is conducted. From the 29 tires surveyed, the mean lifespan was 50,200 miles. Using alpha is equal to 0.05, does the data indicate that the tire lasts fewer than the manufacturer claim? And I just realized I'm in Magic Ink, which is why all of my stuff just disappeared. So we're going to go back and re-highlight. Okay, here we go again. So it's going to be, the average is this. We have a population standard deviation, 29 tires surveyed. In that survey, we got that, and there's our alpha. Alrighty, so it says, what is the null hypothesis? Well, my null hypothesis is that mu is equal to 52,000 miles. What's the alternative? It's going to be that mu, and let's see here, it says, does the data indicate that the tires last fewer miles than the manufacturer claims? So that's going to be less than 52,000 miles. Whatever number you put here, that's the historical data, always goes here. What we're testing goes here, and we need to see if we can substantiate beyond, if the evidence substantiates beyond any shadow of a doubt that the average miles is less than what the company claims. And then it says, is this a T or a Z? So everybody type in, is this a T or a Z? I'm not going to show it until I hear a whole bunch of beeps, and then we'll make sure everybody's... Actually, I think you all can see everybody else's response, right? Excellent. Very good. So we'll go ahead and put this stuff in here, that it's a mu is equal to 52,000, 52,123, and then that mu is less than 52,000, 52,123, and it is a T or a Z rather statistic. And we'll submit our answers and then move on. Okay, so we have all of that right so far. Now let's go find our test statistic. So our test statistic is going to be equal to this. So Z, so let's see here. Mu is 52. We have N is 29 tires. Sigma is equal to 8,000. X bar is equal to 50,200, and alpha is 0.05. It is a one-tail test, and it is a left tail test. And I know that because that's pointing to the left. Okay. So draw our picture, and it's going to look something like this. We can find we're testing at alpha is equal to 0.05. It's a one-tail test. So alpha is all going to be right in here, 0.05. And I'm going to have a negative Z star. And my Z star is going to be 0.05. Okay, so everybody can see, everybody type in what is your alpha or your Z star going to be that we're using. We're going to put in the value that WebWork would expect, and what is that number? Does everybody see it? What's my critical value for Z? My critical Z star. Anybody brave? I hear one person. Both of you are correct. Mallory, I think you're going to find that WebWork requires 1.65. It's going to be negative also, Jessica, because it's a left tail test. Okay? So it's going to be negative 1.65, Jessica. Are you good with that? Good. Okay. So it's negative 1.65. I like 1.645, but I will put in what WebWork is expecting. So it's going to be negative. Oh, that's your test statistic right there. They don't ask for the critical, sorry. So, okay, so now we have our picture drawn. Now we need to calculate our test statistic. Our test statistic is Z is equal to X bar, 50,200, minus mu, 52,000, divided by sigma, 8,000, divided through by the square root of n, 29. We're going to put this in our calculator. And we're going to find out that parentheses 50,200 subtract 52,000 close parentheses divided by open parentheses 8,000 1 2 3 divided by the square root of 29, come out from underneath the curve, close parentheses, hit equal, we get negative 4 places, so negative 1.2116, and that's going to become a 7, so it's 2117. So 2117. So it's negative 1.2117. And so that is actually going to be right about here. Right in here is negative 1.2117. So in here is my fail to reject. And right here is my reject. Right there. And I think this is my red. And this should be my green. And so based on my picture, everybody, am I rejecting or am I failing to reject? Based on my picture and my test statistic. Correct, Jessica. Very good. Very good. Very good. Excellent. Okay. So we shall fail to reject. And our p-value. Now our p-value, it's a one-tailed test. So it's the area in underneath the curve from the test statistic to the closest infinity, or well, in this case, the negative infinity, because it's a one-tailed test. So it's all of this area in here. So now we're going to look up negative 1.21. So negative 1.21, negative 1.21. So our area under the curve to the left is the 0.1131, so that's 1131. So this is 11, oops. Now, 1131. And so that area right under here is 0.1131, right in there. Okay, so let's go see if Webwork likes our answer. 1131. So 0.1131, and then our test statistic was 2117. Negative 1.2117. Submit answers. And let's see what the tolerance is. Very good. Okay, so we're set. So we failed to reject. So this one here is failed to reject. If I fail to reject, that means there is not sufficient evidence to conclude that the mean lifespan of the tires is less than 52,000. There we go. And let me highlight that last little bit here. So we fail to reject. There is not sufficient evidence that it is less than. Alrighty, any questions on this problem from everybody who's attending the session? Okay, is it becoming a little bit clearer, a little bit more confident? Is everybody becoming a little bit more confident with hypothesis testing? Very good. Well, we've got 30 minutes left, so let's go ahead and get busy for the next 30 minutes and see what else we can get taken care of here. So next problem. Here we go. Let's see here if I can make it so we can see everything. There we go. And we're going to come in here and insert screen clipping. How about, we'll look at this one here. I'm going to open this up a little bit. Sometimes I end up having problems with that, but we'll see if I can make it. Okay, the manufacturer of a dental anesthetic estimates numbing on average is 10.75 minutes after injection. The manufacturer has developed a new formula which they claim acts faster than the old formula. A dentist tries the new formula on 11 patients and finds that the numbing happened on average after 9.79 minutes after injection, with a standard deviation of 1 minute. Should the dentist believe the manufacturer's claim? Test at alpha is equal to 0.1. Alrighty. So everybody, I just want you, I'm going to give you all about not 2 seconds, how about 30 seconds. I want you to write down the information. I want you to start solving this on your own as we go through this, okay? So gather the important information, and I'm going to do the same thing. I'm going to write down what I consider to be the important information. I'm just going to quietly work the problem, and I want you to start working this problem quietly. Okay, so as I get busy on this problem, I'm just going to start writing down information. So it says the manufacturer of it says on average 10.75 minutes. So we're going to be doing a mu. It's going to equal 10.75 minutes. The alternative hypothesis. So what we're saying is that we're testing that the new one is faster. Think about faster. Faster means that the time will be less, that it is going to be shorter. So we're saying that mu is less than 10.75. Is it going to be a T or a Z? It is going to be, I didn't finish writing down my stuff. Let me write down all my stuff. Sorry. Here I am jumping the gun. So mu is equal to 10.75. N is equal to 11. X bar is equal to 9.79 minutes. S is equal to 1. And alpha is equal to 0.10. So I have a S because I have a sample standard deviation. And so I'm going to be on a t-test. And that's all right there as far as I got. So let me see how everybody else is doing before I go any further. Let me go ahead and fill this in. So it's mu is equal to 10.75. Mu is less than 10.75 because I need to substantiate the claim. It's going to be a T. Submit answers. And there we go. Okay. How did everybody do on that part? Just getting the problem set up. Did you get the problem set up correctly? Very good. Everybody got the hypothesis correct? That's excellent. Okay, everybody go ahead and quietly, yeah, like you all can really, like I can hear you, sorry about that. Calculate the test statistic and then do the p-value off of your tables. And if you want to try the calculator, go ahead and try the calculator, the p-value calculator. And I'm going to keep working quietly. Let's just see if you can get it all the way through. I'm going to give you about 30 more seconds before I start solving it on the board. I'm going to have to clear that out. I don't know how to get out of that when I do that. Okay, so I ended up with a test statistic of -3, how many 4 decimal places? So -3.1839. The 9's going to round up to 10, so it's going to be 1840. So -3, 1840. So -3, 1840. So it's going to be a T, and it's going to be -3.1840. Let's make sure we got that right. -3.1840. Submit. Very good. How many people got the correct test statistic? Very good, Jessica. Excellent, Andrew. Very good, Riley. Very good. Okay, excellent. Okay, let's go over. I'm just going to throw this in over here real quick. So this was a -3.1840. And my degrees of freedom was at 11 was our sample size. N is 11, so that means my degrees of freedom will be 10. 10. And I'm not going to worry about that. We were a one-tailed test, if I remember correctly. One-tailed test to the left. And calculate my p-value. And did that calculate it? I guess it did calculate it. There we go. So 0.004876. Yeah, so it's 0.004876. I think when you put it in WebWork, you have to go to 4 significant digits, so you're going to put in this whole thing. So it's 0.04876. So 0.004876. And let's submit that and see if that works. It did. And let's come back over and finish it up properly over here. So this was 0.004876. If I was going to use the tables, I would take this value right here, and I would, let's make sure we write up here that our degrees of freedom is equal to 10, and we are testing at alpha is equal to 0.1. So I can just, I want you guys to know how to find your critical value. So go find your critical value if you haven't already done that, while I draw a quick picture of the problem here. And we're going to put a, let's see here, 0.1. So at alpha is equal to 0.1, not 0.1. 0.10. So I need to look up a negative T star. And my negative T star, so right in here, I have 0.90. This is my fail to reject. Here is my reject. Reject, maybe I'll spell that or not. And so this is red. This is green. So now we're going to plot on here our test statistic, but I can't plot that till I know what my T star is, because I need to plot it in relationship to my T star. So my T star is going to be negative, which I put on there. So negative T star, and that's going to be at 10 degrees of freedom, and at alpha is 0.10, and it is a one-tailed test. So 0.10 right here, one-tailed test, 0.1, and we are at 10 degrees of freedom. So it's 1.383, so 1383. So 1383, So 1383 negative. So it's negative 1.383 is my T star value. My test statistic is at a negative, way out here, negative 3.1840. So clearly, in this case, also based off of our p-value, we are going to reject because there is sufficient evidence to conclude that the numbness is less than 10.5 minutes. So we'll go ahead and fill all of that in real quick on the rest of our web work. Oops. And so we are going to reject because there is sufficient evidence to prove that it is less than, and submit. How is everybody's understanding on the test Thursday? Thank you, Andrew. So going back to that, so here we go. Very good, Jessica. Let's double check that you are correct. I think you are. So our test statistic is negative 3 point, so don't worry about the negative when you're looking up alpha, but it's 3.184, and we have 10 degrees of freedom. So we have to come in and find, so 3184, I gotta remember that. So it's a one-tailed test. We've got to come in for 10 degrees of freedom, and we find the interval that encompasses the 3184, which actually 31.84 is greater than this value. Let me make sure I have my test statistic correct. 3184, yes I do. So 31.84 is greater than this number. We have to go in at the number of degrees of freedom that we have. So we're on the 10 degrees of freedom row, and we find the interval that surrounds our test statistic. So our test statistic has to be in the middle. So our test statistic has to be greater than the value to the left, smaller than the value to the right. And if you look right here, 3.184 is between these two values right here. Once you know that, then you go straight up to the one-tailed test, because it's a one-tailed test, and you look at these two values, and this is the boundary. Now the smaller value is here on the right, the larger value is here, so we would put 0.0005 is less than the p-value, which is less than 0.005. So this is how we would write this. We would say that .0005, oops, sorry about that, 0.05 is less than our p-value, which is less than 0.005. That's how you would write that on the test. And if you look at this number, you will see that this number falls between those two values. So it does work. So on the exam, what am I looking for? I'm going to be looking for, let me go into highlighter mode. This right here. Okay? That's what we're going to be looking for on the exam. Yes, Jessica, it is, and that's okay. Yeah, it just takes practice. It just takes practice. So Andrew, are you good now? Correct. You are not using the calculator link because on Lockdown Browser, your whole system's locked in. You can't surf the internet. Okay, good. Riley, how you're going to show work on the exam is like this. Have you all gone and taken the practice exam yet? Okay, good, good. So when you come in on the practice exam, let me see if I can do this. Whoops, let me not. Let's come in here. I'm going to switch to my college algebra, so in case I make a mistake. I don't make a mistake on your all's exam. So I'm going to come in here, and I don't know if I can do it on this one or not. We'll try on the practice quiz, and if not, yeah, I can't do it on the practice quiz, so hang tight. I'm going to pause the video on this so I can record. Okay, so what I'm expecting is this. I'm expecting you guys to, first off, when you turn on, you have to take that test, you know, the little quiz that I just had. And you need to show your environment, okay? I've got some students in my algebra class that did not show their environment properly, and I'm going to be emailing them privately, because I can go in and I watch everybody to make sure that your environment is the way it's supposed to be. And so you're supposed to show the surface area of your desk, that you don't have a textbook out or notes out that you're not allowed to have. You're supposed to show your calculators and things of that nature, that all your resources and everything, you're supposed to show your environment all the way around. And so the test is going to be, we have an hour and 15 minutes for the test, typically, due to not technical difficulties, due to the fact that we're doing this differently than we normally do, and the fact that this is new to everybody, and the fact that this could cause a stressful situation. I'm going to allow a full 2 hours for you to actually take the exam, okay? And then I will actually have a 2.5 hour window open. So I'm going to open, so like your exam starts at 9:30 in the morning, and I have it going where if you were going to take it for 2 hours, then that would close at 11:30. But so I'm going to open it at 9:15, and then you have a 2 hour window from 9:15 to 9:30, 10:30, 11:30 to 11:45 to complete that exam. So whatever 2 hours you want in that 2.5 hour window is what you're going to have to take and complete that exam. If you don't start the exam until 10 o'clock, you're not going to have a full 2.5 hours, okay? Yes, it is Central Time Zone. And if you are, Mallory, if you're like far away and it's not convenient for you to take it at the normal time, then just send me an email and I'll work with you on that. But the tables are going to be embedded in the, hang tight. The tables are embedded in the